So welcome back. Let's take a look at question 18, and this is at the end of the chapter 10. So chapter 10, if you have the full version of it. So let's take a look at this question. So Chelsea is selling celebrity magazines every Sunday, and what she's done is she's collected, as you can see here, let me just capture that. She's collected her demand over time, and she's worked out the probabilities for each. So how often does this occur? So let me just grab this here and pop this onto Excel. Okay, so I'll just pop this right here, and let me just make this a bit darker here. Okay, so let's take a look. So again, she's been meticulous with collecting, how much demand did I have. And if you see here, 125 magazines, the demand for that happened 30% of the time. So that was the most, prevalent in terms of occurrence. And probably the second most popular was demand of 100, which happened 25% of the time. And then after that, 150 happened 20% of the time. So this is what we would call a discrete general distribution. So this is something that she came up with by collecting data. Now, what we can do when we're working with, and again, we want to have Excel. If you remember from before, when we have a simulation, we're going to have a random variable, right? So, and again here, random is open close bracket, and again, as mentioned before, it chooses a number between 0 and 1. Right? So it randomly chooses a number between 0 and 1. And if you remember from before, probability follows between 0 and 1. And as I mentioned before, 0% chance of something occurring means it's pretty much not going to occur. And if something has a, pretty much the probability is 1, it's going to occur. And of course, if probability is 0.5, then it's got a 50-50 chance of occurring. So again, it's picking a number between 0 and 1 with the random variable. So what we want to do is we want to have it set up such that when we pick a number, it's going to see where it falls within this probability distribution. So we would make what we call a lower interval, and we would make an upper interval. Okay, and let me put that in bold as well. I'll just make this a table. Give it some thick borders to draw attention to it. And we can probably take this. I can probably do borders all around. Okay, so what we want to do is the start of our lower interval starts at 0 and it goes all the way to 1, which captures anything that the random variable is going to be, and it's going to look it up within that area. So we would start off as 0. Okay, and the upper interval is going to be the difference between this probability and this lower interval. All right, and you can see, so if, for example, we have a random number and it's between 0 and 0.05, then it would spit back the demand as 50. Okay, now in terms of the lower interval is going to be equal to the previous upper interval. Okay, and don't worry, it's not, when you pick a random number, it's not going to be 0.05 and that's it. As you can see from below, it's picking a number. So it's going to fall within one interval or the other. And I've got the equation, I can just copy that equation down. And as you can see here, the probability is 10%. Well, between 0.05 and 0.15 is 10%, right? So if, and this is going to capture that sort of 10% chance of occurring. And let me just copy this down. Okay, so as you can see, between 0 and 1, I got everything covered here. And take a look here. I can click on an empty cell and press delete. It'll recalculate. So 0.196, I would look here, 0.196 would fall between here and here. All right, and then it would spit back that the demand is 100. All right, let's try another one. Okay, 0.99. So 0.99 would fall between 0.9 and 1, and it would spit back a demand of 175. Let me just press another one here. 0.6. 0.6 is right here, and it would spit back a demand of 125. So notice that the probability of this happening is 30%, and notice that the interval is 30%, right? So the 0.4 plus the range of 0.3 gives us 0.7. So between here and here is a 30% chance of happening. Okay, because again, it is random. So between 0 and 1, there should be a 30% chance of falling between 0.4 and 0.7. Okay, and take a look here. You'll see between 0.15 and 0.4 is the probability of 0.25, right? So this is representing that particular area. So again, even though these are random numbers, they're all equally likely of occurring. But in terms of plugging into this and following this distribution, it's going to mimic this distribution just based on things that have a large, I guess, probability of occurring, such as 125 has a 30% chance of occurring, and that's mimicked by the distance between 0.4 and 0.7, right? When we're looking at something between 0 and 1, 0.4 to 0.7 captures quite a lot of it, right? It captures that 30%. Now, when we're using Excel, we only need the lower interval. All right, so I'll put that in yellow. And remember, inputs are in yellow. Okay, and then it would spit back the demand. So that's all it needs in terms of lookup. We only have the upper interval for us, for the humans, right? So that we can see, yes, it's in between here and here. But all Excel needs is the lower interval. Okay, so let's grab the information on Chelsea's situation. Okay, so she's ordering 100 magazines at a time. Let's see, Control C. Okay, so I'll insert a text box like so. Just pop that in there, and I'll make this nice and large. There we go. All right, so part A and part B. Okay, so it looks like she's ordering 100 magazines at a time. All right, and when she buys a magazine from the supplier, she pays $2 for it, and the cover price, what she's selling it for, is $3. Now, if not everything is sold at the end of the day, she can go to the supplier and get reimbursed 75 cents. Okay, and again, so she paid $2 for it, but if she can't sell it, she can at least get 75 cents for that. Okay, so what they want us to do is simulate 1 year, so 52 Sundays of operation to calculate Chelsea's total yearly profit. Okay, let's do that then. Let's get 52 Sundays. So here we can have the weeks, right? So there'll be 52 weeks, right? And every week is landing on a Sunday when she's at the mall. And again, all I need is 2 for Excel to figure out the pattern. And then I could just hold down my mouse button, stretch it down to 52. There's 52 right there. All right, so 52. And then we've got to figure out demand. But just to show you, just to let you know what it's doing, let me just put in something for rand. We'll put in the random number. Okay, so in this situation, we can just do rand and then open close brackets like so. And we can double click that. And next we can choose demand. So what demand is going to do is it's going to look up this random number and look at where it falls. Where does it fall? In what interval? And based on that, it'll spit back a demand number. Okay, so what we want to do is use the lookup function to look up the table. So lookup. Okay, and then it's going to say lookup value. So let's look up this random number. And the lookup vector. So look it up on this vector here. And then comma. And then it's the result vector, right? So spit back this. Okay, now because we're going to keep referring to that table all the time, I'm going to just highlight this. And on my computer, use the function F4. I'm going to hit that just so it locks that in, right? So it makes it a absolute address. Okay, let me copy this down. Okay, so take a look here. So for week 2, it's 0.06533. So 0.065. So it'd be between here and here, and it would spit back 75. All right, let's look at this one here. Number 3 is 0.3157. 0.3157 would be between here and here, between 0.1 5 and 0.4, and that would spit back 100, as you can see here. Let's find a big one. Okay, so let's see here. Week 10, it's 0.94 on mine. So 0.94 is between here and here, and it would spit back 1.75. Okay, so you can kind of see how it works. It looks at this number. Where does it fall in the interval? All right, and then from there it spits back the appropriate demand. Now I don't need this column here. I can build it right in. I just put this column B just so you can see how it works in terms of it looks it up, and then it spits back the appropriate demand based on that. But I can go into, instead of looking at B2, I could just put the random variable right in there. All right, so I could just type in RAND, open close bracket, so it's going to be looking up this random value itself. All right, then I'll double click. All right, and then it sort of reloads, and you can see based on that it's got the random, you can see the random number there. So I don't need this anymore, so I can get rid of this, and I can just delete it and it'll move over. Okay, so we got demand, and then we've got the revenue, and then we've got the cost. All right, and you folks are business people. You know that if you got the revenue minus the cost, then you can get the profit, which they're trying to figure out. All right, now let me just get rid of this here. Okay, so we're going to be building some formulas, and instead of putting in the raw numbers, we'll have it referring to a cell. All right, so we'll have the number in a cell and refer to that. So because if there's any changes, we just update that cell. Everything else updates, which is nice. So first one we'll look at is she's ordering 100 magazines at a time. So we would just call this order amount. And we just click this on as 100. All right, so she's ordering 100 at a time. And the cost per issue is $2. Right, we got the $2 right here. $2 per issue is what she's paying from the supplier. So we could just pop that in as $2. And the revenue per issue as you can see here is $3. All right, so we can put that in as $3. Okay, so anything sort of unsold reimbursement. All right, so unsold reimbursement, she'll get 75 cents back. All right, that's what they're saying for that. Okay, so we can pop this into a table just so it draws our eyes. All right, let's get some thick borders around there. These are inputs. The inputs are in yellow. All right, so let's just highlight that in yellow. All right, the simulated part is highlighted in light blue, which is demand. So demand is simulated. Okay, and it's following that discrete general distribution that we have in this table right here. All right, so we'll make that a nice light blue, and the lighter the better, just so that we can more easily see the numbers, which are in black. All right, so far we got all the information, but one thing we notice is that she's ordering 100 at a time. But notice on certain days, demand is 100, it's 125, it's 150, some days it's 175, you know, that can happen. But remember, all she has is 100. So there's many days people are walking away saying, oh, I wish I could have that celebrity magazine. Now I don't know what the celebrities are up to because I can't get that magazine. So what you'll see is revenue differs based on demand. All right, so when demand is 100 or more, she sells out. Okay, so again, she would sell out here, she'd sell out here, she'd sell it here, sell out here, sell it here. But there's certain days where she's got 100 magazines, she doesn't sell out. So for example, 75 here, 50 here, 75. So she doesn't sell out, and she has to send some of those back to the supplier to get some money back. So our revenue is dependent upon what the demand is. All right, so what we want to do is just, let me just sort of scroll down here, I'll just add that in. So revenue when demand is 100 or more is basically she sells out, right? So again, it's going to be equal to 100 that she brings in, okay, multiplied by $3 an issue, right? So that'd be 300. But when demand is less than that, all right, so the revenue when demand is less than 100. Okay, there's going to be two components of money coming in. There's money coming in from what you sell, and there's money coming in from the reimbursement. All right, so in this case here is less than 100. So let's just say that it's X, right? So whatever this number is, and X, it looks like in this case, can be either selling 75 or selling 50. All right, so it's going to be equal to X multiplied by $3. All right, plus the amount of money coming back by reimbursement. And the amount of money coming back by reimbursement would be the 100 issues that she bought minus whatever X is. So X could be 75 or it could be 50, and then multiplied by what she gets back. So she gets back 75 cents on that. So notice that in this case, when your revenue is actually going to be a lower amount if demand is only 75 or 50. So that's a situation where you've got to send some issues back and get reimbursed for that. So that means money coming in has two components, one from sales and one from reimbursement. Whereas when demand is 100 or more, it's just straight sales. There is no reimbursement because you're going to sell out. So we've got to put in here some kind of if function that looks at this demand and says, hey, if it's 100 or more, follow this formula here. Okay, now if it's less than 100, follow this formula here. So we'll need to do an if statement. So if you've never seen an if statement, luckily it walks you through it. All right, so you just do an if. Okay, then we have a logical test. The logical test is if this number here is greater than or equal to 100. Okay, so again, we don't put in 100 because we may order different amounts. And if we put in 100, then we'd have to make all these changes, whereas this automatically changes if we refer to the cell. Now, we're always going to be referring to it. So for mine, it'd be function F4, and that would make an absolute address. Okay, so if it's saying, hey, if B2, which is the demand right here, is greater than or equal to 100, then the formula is just 100 times 3. Right? So again, yes, demand is 150 in this case here, but remember, you're only bringing in 100, so you can't sell more than what you actually have. The most you're going to sell is selling out, which is 100. So in that situation, it's going to be this multiplied by revenue per issue. All right, and that's how much you would earn. Okay, and again, since I'm always going to be referring to it, I'm just going to highlight it, and I'm just going to do function F4. Okay, now if it's false, if it's not the case, then what is my revenue? Well, then I'd have to use this formula down here, which is this amount here. Okay, and we would let that float, all right, because we would be checking this amount here multiplied by $3 per issue. And again, we want to lock that in as absolute address. Okay, plus the addition of money being reimbursed because you didn't sell everything. Because remember, if it's greater than or equal to 100, then it's just 100 times the $3. But if it's less than that, right, the value, if that's false, if that statement's not true, then it's going to be whatever this is multiplied by the $3 plus the reimbursement amount. Okay, and what we'd be doing is it'd be 100. All right, and again, I've got to make this an absolute address. All right, so function F4, and then we would subtract that from what this is, and that's how many I would have left over, and then that would get multiplied by the unsold amount. All right, so the difference between the two is the unsold amount, and again, I would need to do function F4 because we're going to be always referring to that. All right, then we close that off with a bracket. Okay, so let's summarize what we have here. So it's saying check this cell B2, right? It's saying check B2 and compare it to the amount that you're bringing in. So if it's greater than or equal to the amount that you're bringing in, then you sell everything. And that is, you sell everything you bring in, which is 100 multiplied by $3 an issue. If that's not true, if this isn't the case, then it's some number less, either a 50 like we have here or a 75. All right, so keep that in mind. So and this area here represents the remainder. So it's going to be 100 that you bring in minus whatever this is. and then multiplied by the unsold reimbursement. Okay, so we hit enter for that, and then give that a double click. It'll copy through. So notice all the instances where it's over 100, so it's 100 more. Revenue is 300, and again, it's because the order amount is 100. We're bringing in 100 and we're selling it for 3. So even though its demand is 125 or 175 or some other number, like say 150, we only have 100 to sell. So keep that in mind. Now notice in the areas where, let's say we have 50, all right, so we have 50, and is that revenue correct? Well, 50 times 3, right? So we sold all 50 times 3. All right, so again, we'll show that to you. It's going to be 50 times 3 plus what we have to send back for reimbursement, which is 100 minus 50, right? Because again, you brought in 100, sold 50, so you're sending 50 back. So then 50 goes back, and then that's being, I guess I don't need the, so 50 is going back, multiplied by the reimbursement of 0.75. Okay, and that's 187. So you see when 50 is there, everything else recalculates. As you can see, that is correct. It is 187. And what about if it's 75? Well, I can fix that. I can just plug in 75 for that. And if I demand is 75, then I'm sending 25 back for reimbursement, right? Because remember, I bring in 100 and I sold 75. That means 25 goes back for reimbursement, and that should give us 243.75, as you see for that. Okay, so that's looking good. Now, in terms of costs, again, we don't want to put in the raw amounts. We want to refer to the cells. So the cost is, I'm bringing in 100. All right, I'm bringing in 100, and it costs $2 per issue. All right, and because I'm referring to these all the time, again, that's the absolute address, and that's function F4. And again, we want to refer to the cells. That way, if we want to make changes, we could just make changes here, and it'll automatically update. And of course, for that, profit is going to be equal to the revenue minus the cost. Okay, we want to just sort of double click there. Now, profit is in dollars, so let's format that. So I just right clicked on my computer here, format the cells for currency so that it's in dollars and it's rounded to the nearest cent. Now notice on days that you sell 50, where demand's 50, notice that you lose money. All right, looks like you lose $12.50. On days where you have 75 for demand, you still make some money. But other than that, if it's 100 or more, you're making a profit of $100. So again, if demand is 100 or more, you're making a profit of $100. Okay, so we simulated 1 year of operations to calculate the yearly profit, and they're saying replicate this profit n times. So they're looking at what is the average yearly profit. So what is the average yearly profit if we do this? Okay, so we'll calculate the average yearly profit, and we'll have it sort of based on one replication. All right, so yearly profit. All right, and that would be just the sum. Okay, because remember, all these profits that we have are for the weeks, but they want to look at it from an annual point of view. All right, so we'd sum those up. All right, and again, notice that on some days you lost money, so that would bring down your yearly profit. So yearly profit looks like it's just under 5,000 based on that. But again, you could choose the empty cell, press delete. Notice how it changes. All right, so it does have some variability here. Now what we want to do, okay, is we can put this into a table. Okay, and also we want to, since this is output, output is in green, so we'll put that into green. But let's make this bold so it pops. Let's pop that into green. And again, we'll make this nice and light so that it's easier to see the numbers there. Okay, so yearly profit based on one replication. And again, one thing that we would do is we would look at, well, what's the average if we do this 200 times? So we would get the, it would be as if she did this for 200 years, right? Essentially following this demand table. If she was to do this for 200 years and nothing's really changing, and it's following the discrete general distribution table that we have here, and if we did those sort of 200 years and took the average, what would that be? And what we'll look at in the next video is we'll set up data table and we'll run this 200 times. And then we would look at, and this is really the key to simulation, which is, yeah, we're bringing in 100 at a time, but what if we brought in a 50 or 100 or 150 or 175? What's the right amount to bring in, if we were to do this, say, over and over again? What would, on average, be the best amount to bring in? So we're bringing in 100, but is it better to bring in 150, or is it better to bring in 75 issues of the celebrity magazine? So again, which one's better? And again, we can take a look and run a simulation. So we'll look at that in part 2.